on the graph of fx equals cotangent of x in the interval 0 to 2 pi, we're asked to find the values of x for which the graph crosses the x-axis. So any graph, it's going to cross the x-axis when y equals 0, right? Make any dot on the x-axis, the y-coordinate is 0. So you're asked for this: 0 equals 0 equals cotangent of x. And we can use the further breakdown of tangent and cotangent. Okay, cotangent could be written as cosine x over sine of x. And tangent likewise can be written as sine over cosine. So in order to make this equal to 0, we don't want the denominator to equal 0. That would be undefined. We need cosine of x to equal 0. So in order to make this happen, we got to find the x-coordinate that's going to make cosine equal to 0. So this isn't the graph of the function of fx. We're just making the unit circle here. Remember, cosine are the x-coordinates on the unit circle. So at this point in the unit circle, since it's a unit circle, it's got a radius of 1. So this is 1 comma 0. This is 0 comma 1. This is negative 1 comma 0. And this is 0 comma negative 1. So cosine of x is 0 in two different spots. It's here because the x-coordinate is 0. And that's a 90-degree angle. In other words, that's pi over 2. And then cosine of x is 0 over here. That's a 270-degree angle, or in other words, 3 pi over 2. So those are the two places that make cotangent equal to 0. Because if cosine is 0, this whole fraction equals 0. And so those are the places where it crosses the x-axis, at pi over 2 and at 3 pi over 2. We're asked when this graph meets the x-axis, and graphs cross the x-axis where their y-coordinates are 0, right? Any dot on the x-axis is 0 on the y. So we need to find out what is a solution to this equation. And so we can break tangent down a little bit further. Tangent's the opposite over the adjacent, so that means if you were to do your fractions and simplify, tangent is sine of x over cosine of x. Okay, so to solve this equation, we don't want the denominator to equal 0 because that'd be undefined. We want to figure out what it takes to make the top equal 0. And so in order to make that happen, let's consider the unit circle. Remember, the unit circle isn't anything scary, it's just a circle with a radius of 1. And the y-coordinates on the unit circle are sine. Okay, so like this is 1 comma 0, so that means at angle 0 degrees, the x-coordinate is 1, so that means cosine of 0 is 1. Sine of 0 degrees is 0. So we just found out an angle of 0 was going to make this whole thing equal 0. Let's find the other ones. This point right here on the unit circle is 0 comma 1. We're looking for where sine of x equals 0 though. Sine is 1 in this position. Keep rotating. This is negative 1 comma 0. So that's a sine coordinate. That's sine where the y coordinate is 0. So that's another place that we want for our solution. So this is 180 degrees. In other words, it's pi in radians. So that's our other place where it crosses the x-axis. And the graph of f of x equals cotangent of x, and on the interval negative 2 pi to 0 pi, in other words 0. What value of x does f of x equal 1? So we want to know when cotangent of x equals 1. Okay, let's see here. You know, you could use graphing software. I've avoided that in the first description. This is desmos.com/calculator, and that's going to get you the answer pretty quickly. But I'm trying to think of the easiest way to do this without a graphing calculator. Here, I'll highlight that for a second. You can pause the video if you want to type that in. I guess the easiest way to think about cotangent of x equaling 1 would be thinking about the definition of cotangent. Cotangent of any angle is the adjacent over the opposite of a right triangle, right? So in order to make this happen, we need the adjacent and the opposite to be the same. That way something divided by itself equals 1. So with our special, like there's certain angles that we memorize their values of, okay? One of the triangles that we memorize is that 30 degrees has 1/2 as a corresponding side. 60 degrees has square root of 3 over 2 as a corresponding side. That triangle isn't going to help us out though, so let's go to the other triangle we have, the 45-45 triangle. We always memorize that square root of 2 over 2 is opposite, and they're both the same. So this triangle would help us out because the opposite and the adjacent are the same thing, right? So we know our triangle is going to be 45-degree angles. So it could be here, could be here. We haven't ruled out any of these yet, but we at least know the reference angle in here is 45 degrees. Or in other words, pi over 4, right? Okay, so to figure out which one's which, it's supposed to equal a positive one, right? So all of them are positive here. All trig functions are positive, so we're going to go with, oops, sorry, 45. So pi over 2 is an angle. That gives us 1 for cotangent. And then another place, all students, sine and cosecant are positive here. Take calculus. All students take calculus. Tangent is positive down here. That means its reciprocal cotangent is positive here. So these are our two triangles. Okay, we're going to forget about these ones because that would give us -1. And so this one is 45, this one is pi plus pi over 4, so that's 5 pi over 4 for this angle here, right? To start from the initial side all the way over here, that is 225 degrees. So we're talking about 5 pi over 4. But they made it a little trickier. We're supposed to talk about just negative angles. Okay, so let me change colors here. Negative angles just mean you're rotating the opposite direction, going like this instead of the usual way. So to get here, like this would be negative pi, right? Going a full 180. So we're not going not doing full negative pi. We're doing negative pi plus this pi over 4 for this 45 degrees. So this angle from here to here is -3 pi over 4. And then we also need to rotate all the way over here, so that's almost a full 360. That's almost a full 2 pi, except there's a pi over 4 in our way. So take -2 pi, but add pi over 4 to find out that take out that small little fraction. So this is -8 pi over 4, so that makes -7 pi over 4. So these two are our solution. -3 pi over 4 and -7 pi over 4. Which of the following is not in the domain of tangent of x? So tangent of x works for all numbers except for something that would cause a divide by 0 error. And tangent of x is sine of x over cosine of x. So what values for x would make cosine be 0? Those are the ones we want to exclude. Okay, those are the ones that would not be in the domain. So we checked this out in a previous problem. To figure this out, we're thinking about where the x coordinates are 0. So here at pi over 2, and then here at 3 pi over 2. So 3 pi over 2 works. -7 pi over 4. Negative just means you're rotating the opposite direction. So that put us right here. Okay, that's not one of our two dots that we're looking for. Pi would put us right here. That would make sine be 0, and that's okay for sine to be 0. We're looking for the values that are not in the domain, so the things that would cause a divide by 0 error. -2 pi over 3. So let's -2 pi over 3 be somewhere over here. And then negative pi puts us over here. So it looks like just 3 pi over 2.